This is a whole digital transformation development. So digital transformation is used to development of new competency, revolves around the capacity to around the more agile, people oriented and innovative, customer centric, streamlined, efficient current time. So it is able to induce, leverage the opportunities to change the status quo and tap into the data world, increasingly unstructured data sources and service driven revenues with the IoT as a vital enabler. So digital transformation efforts and strategies are often more urgent and present in the markets with a high degree of the commoditization. So these things are making the all our life and our society is making the more easy way to we can access to our informations, our data from the internet way without moving nowadays anywhere. So the digital transformation has end-to-end, giving the end-to-end experience to customer experience or people experiences. It is optimizing the making the decision way to how to process to optimize without just moving multiple people or multiple involvement of the anyone's. We just sitting on the places and we can do to make the from beginning to ending the whole data. We can do that things. Operational, they have the operational flexibility. We can change our operations, what type of calculation we can use to can be accessed. Innovation or key drivers, they have providing the whole new innovation based on our experience. We can change and we can innovate new things with the help of this. The goal of whole digital transformation is improve the productivity, efficiency and performance of the whole system things. Digital transformation components, they what type of component they are providing? They're providing the trust that protect organizational data and people's data. Organization, people, data, all information we can trust that whatever we are accessing, whatever we are seeing, those are the trusted information and trusted data things. Collaboration, they provide to create and productive workplace to embrace the diverse work style. Then in mobility, it enable to enable to people to do things, to get the things done anywhere, anyhow. Intelligence, they provide the insight to drive faster, better business decisions. They give that transform the analytics is the transform your companies or information data, what is data to reach a visual and analytics for the better decision making things to help. So this is the whole concept of the digital transformation. But when we see about this digital transformation, where it comes, so we can imagine that we have that industrial revolution or industrial industrial evolution or upgradation. So like it comes to this way. So comparison of changes influence the industrial revolution. We have industry 1. First industrial revolution comes to when steam engines come. Second, in electrical energy is innovated, then it comes to second industrial revolution. Third, when computer and internet introduced in our life and our society and our industry, that is changed our second computer internet. That is third revolution. And fourth one, that is current time. Whatever is not current time, it is not done. It is just beginning. No, not only industrial, it is also in our life, in our societies too. So fourth industrial revolution comes to AI plus big data, hyperconnectivity, like AI, data networking. They are repetitive learning of the vast data. They giving us industrial transformation, social progress, and change of our personal lives too. So these are that is the industrial revolution. So industrial revolution 4.0. So current time, this all technologies, what advanced technologies we have heard about, the AR, VR, blockchain, system integration, adaptive 3D printing, big data, AI, cloud computing. This all is part of the helping to realizing our industrial life. But in here, today we are going to more focus about to each technology. They have their own life. There is own different things. So each technology has their huge scope of for the work purpose and for the study purpose thing. So today we are more focused about this artificial intelligence, how to this help to revolute our industrial. So artificial intelligence plus big data plus high internet connectivity can change to everything. Data. So it changed the digital transformation of industrial, it changed the life, it changed the improve our social life and all things that we are doing currently. So before that, going to more depth of AI, just get into some understanding of AI. What is the real and artificial intelligence? That concept of AI is the science and technology that perform human intellectual function with the machine. Its growth is rapidly advanced in the 2000s with the growth of computing power and emergence, excellent algorithm, and accumulation of data from a widespread penetration. So you can see they have data and development, two things. Data, as we know, data annual accumulation data is current time is 15.5 zettabyte till 2015, and 2020 it has a 50.50, and in future assume that is 2025 we have 175 zettabyte data, equivalent to the 175 trillion of 1 gigabyte things. The development of this, we have penetration optical cable based on high speed internet and speed of wireless network and internet of things thing. So this is AI. In utilization form, the AI can perform machine learning, have cognitive functions such as verbal, visual, and auditory, and understand interpret the situation. It can create a new added value through the convergence. So impact of this AI, it has the international organization and global consulting institution are paying special attention and ripple effects of the AI, artificial intelligence things. So that is the basic concept, but really what is the artificial intelligence? So it is a one of the famous professor at John McCarthy from Stanford University. He had explaining that what is the artificial intelligence. He is defining that the science and engineering making the intelligent machines, especially intelligent computer program. It is the related to the similar task of using computers to understand human intelligence, but AI does not have confined itself its methods that are biological observable. So yes, but what is the intelligence means? Intelligence is the computational part of the ability to achieve goals in the world. Varying kind of degrees and intelligence occur in the people, many animals and some machines things. So isn't there solid definition of intelligence that does not depend on the relating to the human intelligence? So that is not a true problem. The problem is that we cannot yet characterize or general what kind of computational procedure and we want to call the intelligent things. So we understand some of mechanism intelligence is not others thing. So this is the exciting other definition, the exciting new effort to make computers think machine with minds in the full literal sense. The study of mental faculties through the use the computational model, a field of study that seeks to explain and emulate intelligent behavior in terms of computational process. So the study of how to make computers to do things at the moment people are better. So these are some basic concept of the artificial intelligence. In the short, every person can be make their own definitions, like any machines can be work like human, any machines can be take a decision like human. That is the intelligence, that is the artificial intelligence, we can think that. So what is the scope of this artificial intelligence, where we can going to apply, what is the reason to we that is taking too much popularities? So we can see that it can be used philosophy and cognitive science, mathematics, psychological, computer science. This all can be making to be combining with those things to make the reasoning, learning, planning, perceptions, knowledge, equations, intelligence search, uncertainty, and manage those whole things that can be possible to make that intelligence of the artificial intelligence. So it can be used for the pattern recognition, medical diagnosis, expert system, NLP, semantic web, data analysis, mining, knowledge representation, and many more of things. So This whole AI or whatever you be going to do, this algorithm, machine learning algorithm or deep learning algorithm, neural network methods, this all is based on, everywhere is based on these things, data. It comes from the data, this analysis. That is a one example of the applications, data analysis and mining. But this all things are based, a whole intelligence, artificial intelligence development is based on those data things. So those data, maybe you guys heard about to the big data word, right? Big data is, that is the means huge amount of data will be stored somewhere. So big data is any kind of data source that has the at least one of the four shared characteristic called the 4V's. That is, 4V's is volumes, extremely large volumes of data, ability to move the data at the high velocity of speed, ever expanding variety of data sources, veracity, so that data sources truly represent the truth. So why we are talking about this data things? Can we this what was this data means? Data is anything. Current time, like what I'm speaking, that is also data, but they have something different, data and information. Can sorry. So that is the two things that we are using. As I mentioned, that whole artificial intelligence is working with the data, right? So data is, we are collecting the information or data, some particular facts, and those facts we are analyzing and two things and make the decision based on those analysis. That is called the whole data process. So whatever the machine learning, data science, data analysis, this is all is evolving with the help of data things. So that is the big data is the important part. They can play for the artificial intelligence. Not we don't require the huge data. We require to related applications data. For example, we are applying some face recognition algorithm to our machine learning things. So what we require? We require some face. We need to train our machine before recognizing, before implementing the algorithm. We require to some our information or data about to how can we recognize those face. So like that is, my face has some eyes, eyebrow, my nose, my lips, my ear size, my hairstyle. They can be detect those things. They can be, we need to give them that information. That is the data. Our face data means what is the structure of my nose, what is the structure of my eyes, what is the how to I'm what is the structure of my hair. That all data we are going to provide the machine, and then machine will be analyze those data and give us to decision that okay, this face looks like who. So that is the whole information, that whole artificial intelligence and those things are based on this data things. So so that is the training, that is called the training of the machine, the training machine learning system. So what that training, we can representation, give the representation, the algorithm create a model to transform the inputted data into the desired result. Evaluation, as the algorithm creates a multiple model, either the human or algorithm will need to evaluate the score and score the models based on which model produces the most accurate predictions. And third, optimization. Optimization, that is after the algorithm creates and score the multiple models, select the best performing algorithm to these things. So before this, to applying this training and those things, we need to do what? We need to prepare the data preparation. That is called the data preparation things. So that is data preparation is the machine learning algorithms. Here I'm talking about I'm putting the machine learning algorithm, but doesn't mean of the doesn't need algorithm for the data preparation. Data preparation is we are collecting data from the our some big data servers, from the what data we are going to provide them to provide to machine. So that is the just I'm using the machine learning words algorithms here, but it doesn't make to any role or to data preparation. That is the algorithm will use to after the data preparing. So machine learning algorithm often get the majority of the attention when people discuss machine learning. However, success depend on the good data. So it is understanding your data is critical to your success. And if you create a model based on the faulty data, or your prediction will be obviously inaccurate. So third, in addition, we need to think about what data should be included in your machine learning applications. So is based on the application implementation, what type of we develop the machine intelligence. Face recognition, market prediction, what are the stock market predictions, and whatever we like householding, like rental house predictions, like in the future, in the near to BHU University, how much price is going to up and low, that can be we can use. So we require that type of some particular specific application based data, we need to provide them. So it has two things. That is, first is called to the data preparation is the structured data sources. Structured data source, that is, structured data is typically stored in the traditional and relational database and refers to the data that has the defined length and formatted. So it has like we collecting data from sensor data, internet data, website data, point to point cell data. We're talking about to some stock market things, when is going to up and low, those data, financial data, weather data, click stream data. These are some examples where we get those data. So sensor data is example include the radio frequency, RFID, smart meters, medical devices, global GPS systems, those data things. And weblog data is like the when servers and applications network and so on operate, the capture all kinds of data about their activity. And point cell data, that I mentioned, that if we are going to predict that what is the price of the near BHU University, so we collect the data from the last few years data, when is price going up and down, and then those evaluation based on those analysis, those data, and we can predict which situation the data is high, with which year data the price going high and which year price going down, and what conditions, then what is the conditions to price fluctuations things. Next we have to the unstructured data. Unstructured data, that is called the unstructured data, has some implicit structure, not specified format. For example, we have text internal to the company, that is think to all of the text within the document, that log, survey, results, and emails, enterprise of the information. It actually represent the large percent of the text information. So in the word, how can we do those things? So like huge amount of word characters we have, but we have to use those data to how can we recognize those things. Social media data has generated from the social media such as YouTube, Facebook, Twitter, LinkedIn. We are posting so many things on the system, sometimes video, sometimes some refer to some link, website link, some YouTube videos, some pictures, those some job related things. So how can we, because there is different applications, different side of data. So how those data gonna be evaluated, those data gonna be analysis by the machines. So that is also unstructured. And mobile data, in our mobile has a lot of applications, lot of different things. Those data also. Satellite data is include the weather data or data that is government capture in the satellites and surveillance imagery data, photographs and videos, radar and sonar data. So these are some examples of two unstructured data things. So next I go to example how to work this AI, understanding of the AI with example. Like we give the input, they find out the low level features, mid level features, and high level features, and then train the classifier and get the output. So for example, this is for example for the image. If I'm giving the images, they give the pixel, find the edges, texture, motif, part, and then it will detect the object, what type of object in that picture, that image has. And if we give the some text, so in text they divide in the characteristics, word group, and clause and sentence and story. They will define that character and find out that what type of word or what type of sentence or what type of paragraph we are giving to system to they detect that things. So these are the example of the artificial intelligence things. These, so you can see in here, this all machine learning and deep learning are based on this process. In a deep this example is about, you can say that this example is about deep learning. If we are talking about to only machine learning things, so in a machine learning we give the input, make it the, we already train the system what type of input we are already given, they match the input with this trained data and it give the output things. That's it. That is the machine learning. So in the deep learning they are finding the low level feature that called the feature extraction. For the versus when feature extraction means, like I give this image, to machine and ask that what is the image of regarding which topic. So what they are doing, machine in a deep learning things, they are extracting small pixels, dividing in the small pixels and finding those things, multiple features like hairstyle, eyes style, nose style, his body style, leg style, and then it will be finding all information in this way, detecting, extracting, and then again they are start the matching with those things, those data, and then finally they say that, oh, this image is the human image or any person's image, like that. So that way, that is the deep learning is extracting to, both are the same, working the same things, but in the machine learning basic algorithm, they just give that, we give them input, we give them output, and we ask them to, we ask them to be how, what output is coming. So like face recognition, I give that all information about my face, we already trained the machine with those, and then we go to front of camera. So means we already give them to my face information, and then I put the camera, they matches both information, they matches my current face structure and what we are already trained the machine, they matches, and then they will find out that, okay, this is the output, this is the professor's face, like that way. So this is the machine learning one. And if we go for the more specific one, if we go for give that my picture, I train my hairstyle, my eyes, my nose structure and all things, give the, they divide in the all things in separate part, they divide in the hairstyle, they divide in the eyes, they divide in the nose structure and everything, and then they are start to matching and give that more accurate that information. So in the machine learning they have a accuracy they can be give this yes or no answer, that is a very few data we have trained. But in deep learning way, we are trained the machine with the huge amount of data, with only for the phase one, each all structures, all small things we have trained our machine. So that is called the more deeper way, that is the different thing. But there is some structures, we're going to talk about those things. So this next we have to machine learning process. The machine learning process do these things. Sorry, it's taking time to. So in machine learning, we collect the data. We have raw data collections. Then we do the data process, train our machine. Then we have to clean the data. Like with my face, there is going to so many background also, those things we need to clean those information. Then after cleaning, we have explored the data with the help of data process. Then we use the AI model or machine learning model, and then we make the communication visualization report and make the decisions, and machine will make the decision, give us to information, and those data are again gonna be stored in the data server where we are using those things. So this is next we have two more basic things about two applications or understanding of the AI. AI we have cognitive learning, judgment and those things. So this is the example of two where we are using to AI and those features. So they have using feature future vehicle, bio healthcare, smart factory, fintech, energy, smart city, smart farm, drone, intellectual government, legal technology. So these are the all, but the process is going to like same way. We collect the data from IoT and those devices, sensor devices, and we transmission use the help of the internet, and then we those are stored in the some servers, big data places, and then we do the data analysis, data accumulation, and make the judgment recognition things. So this is the whole artificial intelligence thing. Next, we have to talk about to this things like artificial intelligence in engineering are making intelligent machines and programs, and machine learning is ability to learn without being the explicitly programmed, and deep learning is a learning based on the deep neural network things. So this whole machine now we're going to talk about to machine learning one. So machine learning has characterized in the four fields like supervised, unsupervised, semi-supervised, and reinforcement learning. As I talk about the supervised one, that is the training data includes the desired output. So what the type of data we are trained to our machine, they have already using to those information. They giving the input, we are already know that what type of output we need. So machine can be just give that output, and we can recognize that okay, this output is correct or not. Unsupervised one, we training the data does not include the desired output. We just give them a lot of data and machine to analyze themselves and give us to some predict the data to output. Okay, this answer has gonna be this type. So we believe like for example, we give them one paragraph to machine, and they that paragraph related with the some other topic, and there is mention some machine information and those things, and the machine this machine will be summarize our that abstract, and they will tell us to how what is the output is coming, what type of output, and we believe that. So the basic example is like we are submitting the some journal paper. So nowadays some journal organizations like Springer, elsewhere, they are providing to what type of like they asking to abstract from us, and they suggesting the which journal is suitable for our paper. So they are using too much this unsupervised one. So we are just providing to information, they analyze those information and give us, and we believe that okay, these are the journals, they can be really that is the most related with our topic where we can to submit this paper like this way. Semi-supervised learning is the training data includes a few desired output, not the complete one things. So I'll give to more example. So and reinforcement learning is a rewards from sequence of actions. In the reinforcement learning has been not giving to anything, the machine, we just give them input, machine analyze those input and learn those input, and then again is asked to agent, asked to us to what is the these things, is it correct or not. Then we give them feedback, we give them reward, okay, yeah, this is okay, this is not. Reward means we are not giving to any money anything, reward means our feedback, we giving the our feedback things. So they based on this. So there is some example algorithms in the supervised sections we are using to this classification. In the classification we use the regression algorithms, that is the statistics. So mostly statistics methods we can use in this, our machine learning algorithm can be used it. So this is regression methods, how can we make the prediction, used for the prediction things. The supervised one, they're providing to clustering and those things, and semi-supervised and semi-supervised, semi-supervised and reinforcement we're going to talk about too in our next coming slides. So how this machine learning works in the traditional programming, what we do, we give them data, we program those data, and computer will be analyzed, do the process and give the output. In the machine learning, we give them out data and we give them output also, and computer will be process those information and it give the program that things. So okay, this program will be, machines will be work like this way. So this is the step involved in the machine learning. They defining the problem, preparing the data, evaluating the algorithms, improving the results, and presenting the results. So this is again giving the machine learning. They have first association analysis, supervised learning, unsupervised reinforcement learning. So association analysis, that is making to, like for example, if we are going to buy a bread, then it is recommending that we are mostly buy the milk with the bread. So that is association analysis. Is machine is advising you to, if you are going to buy this, then you are also buy this. That is the affiliation. You are mostly, whenever you use things, like example, we are watching some YouTube video, sometime we are watching some comedy serial, so they are always giving us to recommending us to, okay, you are watching this comedy serial, there is another videos also related with that comedy, so you can watch that one also. So they are just a recommendation based on the our action, based on our action, what type of we are doing things. That is the association analysis. And supervised, we already talked about, they have giving the classification and predictions, those things, making the classify, this is like human, this is the animals, they giving that type of output. Predictions, they can predict in the this supervised one, they can provide the prediction of the based on experiences, based on the existing data, they can predict what gonna be in future things. And this unsupervised learning and this reinforcement learning things. So this is the example for the supervised learning. We have internet data, eat, run, sleep, drink, work, play. These are the data. How to actions when we are eating something, when running, when sleeping, drinking, work. So what is these things? We have trained our machines, and then we are give the goal, click on the systems, they make it the price and those things, and it gonna be give that users and giving the some recommendation. So this association is also part of the supervised learning things. Next, in here we can see they are classified data, each and specific, eat, run, sleep, drink, work, play, that way. Second, we have to unsupervised learning. That is the, we have input the raw data. There is a huge amount of data. We are not classifying that which is gonna be what kind of data we are giving. So then it will be unknown output, no training data set. They have that interpretation, and then they using the algorithm, make the some logic, make the clustering. Okay, which one is making based on this feature extraction. If we are giving some apple, banana, and pumpkin, so many pictures of the whole mixed picture of the fruits and vegetables, so that we just give them those information. So machine will be classified that which one is belong to fruits, which one is belong to the, make the group of the clusters, making the clusters belonging to fruits, belonging to vegetables. That type of information they do by this unsupervised learning. Next, we have the semi-supervised one. That in semi-supervised one, we have the input layer. We have just collecting the data from the, okay, we getting the data from education institution. So there is all data must be related with the education things, not the related with the any movie, not related with any other related things. So those education's data we have to giving the some supervised one, semi-supervised, like we have classify some student data, professors data, and those things, but we are not telling that what exactly those data is there. We are just telling that this is the some student related data, this is the professors related information, and that is the administration related things. But inside of there is so many things, students courses, students grade, students class, and those information that is by doing by themselves. The machine will do by themselves classification. So they have to this semi-supervised SVM. They using the improved LXNet network, that is the neural network that will using to softmax and hidden layer, finding the hidden layer and giving the output of things. And they are classifying that, okay, which one is related with the students, what courses and those things, which one is related with the other things, those informations. Third, fourth, we have to reinforcement learning. In reinforcement learning, if you see, in the reinforcement learning, we have trained this in the picture is showing that we are trained one dog, right? So what we do, we are throw this stick to outside and dog will be go and catch it and bring it, right? So those things is based on, like, once we throw, dog didn't bring it, then we tell to them and we given the feedback, go and take it, go and bring it, go and bring it. Once again he bring it the which different side, bring it any other things, then again we train to dog, and then it will bring it, then it will gonna be. So we based on the feedback, our feedback, dog actions and dog activity has a change. And finally when dog bring this sticks directly only one time to, that is called to the reinforcement learning. That means once there is done, so those information is stored in the dog mind, and those things is gonna be repeat again. So same thing we do the with machine. We give them machine to some action and some data, and they will be do the some action, and based on our, again we give the feedback, and based on our feedback they are going to, based on their feedback they have do the again next action things. So this is complete for all machine learning things, machine learning methods. So let's see one by one. Before that, these are the some algorithms. Supervised learning has a decision tree, ruled inductions, instance, Bayesian, neural network, support vector machine, model in symbols, unsupervised clustering, dimensionality reductions. Those are some examples. So here going to talk about, this is the association analysis example. We have like P, Y by X, probability that somebody who buy the X also buy the Y, where X is the Y are products and services. For example, P chips or beer, 0.7, that market basket transactions. If you go to buy the bread, you can suggest buy the milk, bread, diaper, beer, X, like these are the some association with each other's example things. Second, we have to supervise more. Practical machines use the supervised learning. They have supervised learning system tries to learn previous example that are given. On the other hand, is unsupervised learning is the system attempts to find the pattern directly from the example given, and they have like speaking mathematically. Then we can say that supervised learning is where you have both input variable X and Y, and can use algorithm to derive the mapping function from the input to the output. So mapping function is expressed y equals to fx, like things. So for example, they are using to classification regression. Classification is the classification problem is when output variable is category of word group, such as a black and white, spam, no spam, those type of grouping. And regression is the problem is when the output variable is a real value, such as rupee, height, and those things. So applications find that classification we can use to this pattern recognition, face recognition, pose, lighting, occlusion, character recognition, different handwriting style, speech recognition, temporal dependency. So uses of dictionary, syntax of the languages, sensor fusion, combine multiple modalities, and example of visual, lip, image, and acoustic of the speech, medical diagnosis, and web advertising. These are some applications of classification things. So I just give the example to, for example, in here we have this 2 apple and 1 banana. Now we use to classify things. We already know those things. When we give the input of this information to system, the machine will be classified this way, which one is the related with the what. So it is finding out that there is 2 red color one is the apple, and this blue color places are belonging to the banana things. So it's based on their shape and their structures matching and feature matching, they have made these classifications. Second, regression problem. So given some data, we assume that those value come from the some sort of function and try to find out what function is it. So is essence, you try to fit the mathematical function that describe a curve, such as the curve passes as closer as possible to all the data points. So regression is essentially a problem of function approximation or interpolation things. And they have some other prediction things like decision tree tools, that is prediction of future cases, use of rule to predict the output for the future inputs, knowledge extraction, rule of easy to understand, compression, rule of simpler to data is explain, and outlier, that is exceptions that are not covered by the rule, like for example some fraud and those things. So this is the examples or uses of supervised learning. Next we have to unsupervised learning, that is conceptually different problem, no information about correct output, what are the correct output we are expecting, no regression, no guesses about the function can be made. The classification is no information about the correct classes, but if the design our algorithm so that it exploit the similarities between input, so as the cluster inputs that are similar together, this might be perform the classification automatically. So in essence, if the aim of supervised learning is find the cluster of similar inputs in the data without being explicitly today that some data points belong to the one class and other in the other classes. So this algorithm has to discover similarity itself, finding the similarity based on that, defining the clustering, defining the feature extraction things. So unsupervised learning problems can be further divided into association and clustering. Association is rule. Learning problem is where you want to discover rules that describe large portion of your data, and such as people that have that X also they buy also X to also buy 10 Y. Clustering problem is where you want to discover the inherent grouping in the data, such as grouping customers by purchasing behavior. So for example, we have this new text we are giving this, they are extracting the feature vector, they are extracting those things, matching. This image is just disappear, some error. So but we have already collecting those data, matching the phrases, matching the characters of the data, character of the text and documents things, and then giving the predict the model and give the expected level of those things. So this unsupervised learning, what normally happens to no output. Clustering is grouping similar instances. Other applications, summarization, association, analysis. Other applications, customer segmentation, image compression, color quantization, and those things. Bioinformatics, we learn the learning the motifs, those things. So next we have to the reinforcement learning. So reinforcement learning is learning data gives the feedback so that the system adjusts dynamic conditions and in order to achieve an objective. So the system evaluate its performance based on the feedback responses and react accordingly. So for example, like this, we have some state based on the environment. The data is going to be the agent do the action, and based on the action is done, then environment again give the response or reward. That agent again improve or not improve or restore those data in their database and do the again some actions. So that is the happening based on the knowledge, learning and environment process is going to be continuously done. So this is the example. We have this environment as 0 environment, there is no action is done, then it is reward, no reward, 0. That is going to state agent is the machine who is going to do the action, machine do the action, and environment again give the decision and make the reward, and again this reward based on reward machine again gonna be repeat those action. So that is gonna be repeatable things. So that is the in here we can see this is the agent, that machine, and environment is we are the environment. We can create the environment according to environment, the actions and rewards and observation is going to done by these things. So this reinforcement learning is based on especially policies, some policies. So policies are what action should an agent take in a particular situation, and utility estimation is how good is the safe policy, reward, value and model of the environments. So there is no supervised output but delay the reward. Credit assignment problem, what was the responsible for the outcomes things, and application is like game playing, robot in the maze, like that type of things. So this is the overall about to the machine learning things. So next we are going to talk about the neural network and deep learning. So before that, if anyone has any question, then you can go with question, or we go finish the after finishing the ma'am, what is the things. Can we take a question now, or
As you want. If you want to embed questions now
so,
up to the top, you
yeah,
can do it. Otherwise, we can do it later also.
okay. So if anyone has question now related till now, then you can answer it, and those questions can be after the completion also. We're gonna be make the summarize.
Dr.
So
Madhusudan, we are having questions in chat box.
yes, ma'am. Where is it? Yes.
So, first question is, what is big data?
Okay. Just this. What is the big data? As I given the example, face recognition, your hairstyle, your eyes style, your spec style, nose structure, ear structure, lips structure, and that structure. We have so many things. So storing those information in the some places, right? Those is the data. First of all, I want to know, you guys understand the data. What is the data? Do you guys understand the data? Anyone who's asked this question? Durgesh, can you answer that?
So it's an information about different things, various type of informations.
Yeah, but there is some confusion. Information and data is some different things. Data can be generate, information is generated with the data from the from the data, but data is information. For example, let's see.
The data is a raw material.
Yes, exactly, raw material. If we ask that, we can make it the some information. These are the some data. Each single character is the data. Okay, and if we get it the those data and we make it the some information, for example, this one and this one, we make it the some like bhu, it has some meaning, right? This is the information, that is the information. So data is the any raw materials, anything. So big data means very huge amount of data. Currently, as we are accessing our phone, right? We are searching the Google and so many things. So they are storing somewhere some information, some data. So where is coming those data? That is the call to the big data. Big data is storing storage place where there is a huge amount of data. For example, in my giving that the definition, when I talk about big data, is big data has this 5V. In here we're talking about to 4 3 V I think, but it has, yeah, this one, 4 V's. Volumes is there is huge amount of information, huge amount of data. Even though that much is data, for example, you are using your computer. In your computer has huge amount of data. They have, like, you have watching the movies, listening the songs, you have your class courses, you have different classes. So those all information you are storing your computer. There has a hard disk that is called a memory. In there you are already storing the lot of huge amount of data, right? But you do sometime when you require something, you need to go to search and then you find out those things. So big data is your own machine is itself related with your some particular applications, is related with those things, that is a big data place. So you can imagine that is one PC, that is your own computer, has a amount you storing those data. But we is talking about to huge amount, means that gigabyte one. When I'm giving that example, like megabyte, gigabyte, more gigabyte, petabyte, and those type of huge amount of data where we are going to store. Those are where is storing, like Google has Google own Google server where they are storing all people. Everyone is using the Gmail, Google services, lot of Google services. So every time they have generating those type of information. So they are providing some places where that Google server or Google cloud, we call that cloud, they are storing our informations. That is the big data. Big data is nothing, is just a huge amount of data or huge amount of raw materials, and regarding to those raw materials and according to our application, according to our requirement, we are searching those there and we get it the making in the information in meaningful data. So big data is a huge amount of data. Okay, just I'll go one by one. So please, cons, that you cons about to the that pros and cons we're going to talk about in the last of the class. but more cons is the drawback. You can assume that people are more lazy, they don't do anything, machine will do everything for me. So that that type of some cons. And the a business point of view, you can see that is the more beneficial, that is the making easy to make the decision, easy to everything, but our brain is going to stop the doing the actions. Now you in your mobile phone has more than 100 contacts. How many contacts you remember? How many numbers you remember? Even the 1 and 2, to accept 1 and 2 mobile number, you not recommend remember to all contacts number, right? So that is some drawbacks of the AI. The mobile smartphone is also automatically is one of the example for this artificial intelligence. They are providing to services whatever you want to. So think about that. This is the mobile one. Then in future, when some small robots is coming and they are doing for our everything, they are cooking for us, they are making food, they are doing everything. Then what we need to do? Just sit and chit chat and eat. Machine they were providing to everything. So that is the cons. And what happened the test case in the new? What was this mean of new? That Alka Jalan, what is your question? Is test case is a new?
Good afternoon, sir.
Good afternoon. Yes.
Sir, my question refers in the for the if the we generally you told कि जो मतलब हमारा जो टेस्ट केस है वो कंप्लीट मतलब जो हम लोग जितना हम ट्रेन किए उसी में से टेस्ट किए.
हाँ.
तो अगर मैं सर मेरा क्वेश्चन ये है कि अगर कोई डिफरेंटली कंप्लीटली न्यू अगर इमेज दिखता है, then what will your machine react?
If the machine is not trained with those data or those image, then machine not gonna give that. They have already data, they are matching with those data. If something is matching, they are just giving the fault answer. If there is a completely new cases, it's not matches with the trained data, trained machine, then if machine is a supervised one, I'm talking about that supervised one. If there is some like reinforcement learning and those things, they again process those data and then giving to again output, and then again if you based on your feedback, okay, this is the correct answer or not, based on your feedback again machine going to work and those things. So that is for that reason it comes to more in deep learning and those things, those methods. We're gonna be talk about those examples, okay? But if we're coming to completely new cases, definitely machine gonna be confused. A machine whatever answer they're trying to match those answer with existing data, trained data. If not getting the answer, the machine not gonna give the back you the answer.
Okay. Thank you.
Excuse me, sir. Sir.
Yes.
Sorry to interrupt you. Good afternoon, sir.
Good afternoon.
सर एक मेरा भी क्वेश्चन था सर कि अभी मैं यूडेमी पे एक कोर्स कर रहा था फेस डिटेक्शन का. तो सर वहाँ पर ऐसा हो रहा है कि अगर मैं कोई इमेज से भी वो फेस दिखा रहा हूँ या अपना फेस दिखा रहा हूँ, तो वो क्या कर रहा है कि वो मैच बता दे रहा है, ठीक है. लेकिन कभी कभी ऐसा भी हो रहा है कि अगर मैं किसी और का भी फेस दिखा रहा हूँ, वो भी बता दे, डिटेक्ट कर ले रहा है कि ये है, उसमें आ जा रहा है. मतलब कोई उसमें मैंने पहले से उसको बताया नहीं है कि ये कौन है, फिर भी वो जो मेरे अंदर मेरा डेटा है, उस डेटा में तो वो एक डेटा बता दे रहा है कि ये आदमी ये है. तो इसको सर और एक्यूरेट करने के लिए क्या करें सर? ऐसा आ रहा है फॉल्ट इसमें.
सो उसके और एक्यूरेशन फॉर द मोर एक्यूरेशन, उसके एक्यूरेशन के लिए आप डीप लर्निंग एल्गोरिथम और डीप लर्निंग मॉडल्स यूज कर सकते हो. दैट वी गोइंग
सर मैं इसमें हर फेस डिटेक्शन के लिए हारकास्टेड यूज कर रहा हूं सर.
कौन सा? हेलो, कौन सा?
हारकास्टेड.
सार्कास्टिक. कैन यू टाइप हियर?
एल्गोरिथम सर.
So that algorithm is not that much effective. So you need to use some more. Is not about the algorithm. It's about to feature extraction. How much you train that feature extraction. So जैसे मैंने एग्जांपल दिया था कि मैं अपना फेस दे रहा हूँ, तो मैं अपने फेस का एक एक बेसिक चीज दे रहा हूँ इन्फॉर्मेशन. लाइक मेरा हेयर स्टाइल कैसा है, मेरी कितने बाल मेरे व्हाइट हैं, कितने बाल ब्लैक हैं, मेरी आईज का स्ट्रक्चर कितना, मेरे आईब्रो का स्टाइल क्या है. सो as much as तुम ट्रेन करोगे मशीन को, as much as the features दोगे, that much is machine gonna be give you the more accurate answers.
Sir, for that I am using sir LBPH algorithm, local
LSTM
pattern histogram. LBPH, local bandwidth pattern histogram.
So bandwidth pattern is bandwidth pattern is not related with the feature matching. Is bandwidth pattern is
binary pattern.
Binary pattern. Sorry, binary. Yeah, binary pattern. So binary pattern they are giving to the some only two values, right? 0101 that thing they are finding to matching those things for तुम्हारे एल्गोरिदम में प्रॉब्लम ये हो रही है कि जो एल्गोरिदम तुम अपने फेस का दे रहे हो सामने जो दूसरा इमेज डाल रहे हो उसका भी फेस का ही है, बट तुम अपने एल्गोरिदम अपने फेस की मोर बेसिक स्ट्रक्चर मोर बेसिक फीचर्स के बारे में एक्सप्लेन नहीं हो पा रहा है, एक्सप्लेन नहीं किया है, तो मशीन सिर्फ अभी रिकॉग्नाइज कर रही है कि ये फेस है कि नहीं है।
तो सर उसके लिए हमें क्या यूज करना पड़ेगा?
अभी आगे आते हैं, अभी बताते हैं।
Shubham, I will give you sir's email ID, okay? And after that, after this talk, you can
yeah, you can contact me. That things.
Yes.
Yeah.
And personally, you can ask him.
So related to your practical one, we will come to after the completing the task. We will come to on the related with your if you are implementing and have some problems, then we can to discuss those things. Related now, I'm just talking about focus about to what I already talked. Okay. So
thank you, sir.
So what is the big data and AI are related to each other? So as I given the example, big data they are providing to data, right? So big data means for the AI related things. If we are going to apply, for example, apply to whole industry, one big industry like Samsung company, they are going to apply their employees are coming or they're inputting in coming or going timing things. So what they are doing, they're like employees working more than 10,000 or 1 million people are there working in that company. So how they manage those 1 million data? 1 million data they require also more accurate answers, right? So more accurate answers for that they require to store those information in very big places, very big huge memory space they needed. So that is the huge space is called the big data. Okay. So that's the way they require the system, the AI and the big data. Machine, how to implement the machine learning algorithm, machine learning in the machine. So we need to provide the train the data. We can use the TensorFlow and those programming, Python programming and those things, programming language, and then you can code those your machines learning algorithm there, and it's automatically gonna be work. So that PyTorch, PyCharm, and Anaconda, those type of some applications. That is basic. That Python is the more simplest one currently programming language the people are using. So I think that way you can implement those machine learning algorithm to use.
Hello, sir.
Yeah.
Yeah. So my question is, sir, how we implement custom algorithm?
Custom.
Yeah. So not predefined.
Now custom algorithm, that means you that unsupervised one, right?
Yeah.
So that you can just provide the data. You give them a huge amount of data, and those data machine going to when you provide this regression and classification algorithm and decision tree algorithm, those type of support vector machine, they are finding two features, extract those features, and they are matching those features and defining make the classification and make them own clustering, making the some specific features related some groups like that way.
Okay, sir.
Semi-supervised learning, as I mentioned, that semi-supervised learning, for example, we have the whole education system. Education university is going to implement the this machine learning or this artificial intelligence in yourself. So what they are doing, they have categorized with the student and professor and their administration worker. So what information that is already we have semi-supervised, we are already informed. There is some 3 categories, and each category has what conditions we have giving that. Okay, someone has talking about class, talking about some professors, talking about to some like grading and those things. We put it that person's information in the student category. Someone is working on the research and working on the managing managing department and those things, we put it in the someone teaching about the courses, we put in the automatically in the professor's database. So when we are going to do the classification, that is the semi-supervised, we already specify students, professors, and administration, and then later on when we are getting the data, automatically the machine will be analyze those data. We are not telling that which data is related to the student, which data is related with the professor. We just giving some conditions, and based on those conditions, machine itself make a decision which is related with the student, which is related with the professor, which is related with the administration things. That's the way. So John McCarthy is didn't mention that he's the father of AI. He's the father of modern AI. You can say that. Alan Turing is the father of that first one who is making this machine logical true things, to yes and true and those things. So that's the way of that the like Alan Turing is we have the study and then Turing machine in the undergrad also. Like Turing machine is the first most intelligent machine. So that time is more Alan Turing is the more accurate one, and McCarthy is the, we can call that modern one. They're giving the this type of definitions things. So we are using to data model. We can accessing the data from the for the data model from big data platform. We cannot cannot if that big data platform is the storage places where data is storing, and there we from there according to our data requirement applications we have accessing those data, we are implementing those data. Okay, so data model will be accessing from the big data and they will apply those things. What is this? Your occupation and designation? This question?
No, this is related to feedback.
Okay. Okay,
someone asked the meaning of that in the privately chat, and I just
yes, Alka, no problem. Dr. Madhusudan, you can now continue, or this is already 12:37, so we can have the next part of your lecture,
yes,
that is deep learning in
that is the most important things. Yes. So okay, so that's we talk about the neural network. Where it comes from the neural network, it comes from our brain things. So they are starting after the machine learning work, they started to think to how can we make it the more advanced the machine will be behaving like this part is making to that machine make the intelligence and work as a human brain, like similar as a human brain. So we have like our biological brain, how it's work. The variety of different neurons exist, like motor neuron on create center of surround visual cells with a different branching structure. The connecting of network and strength of the individual synapses establish the function of the network. Dendrites are nerve fibers carrying electrical signals to the cell, and cell body computes non-linear function of its input, and axon is a single fiber that carries out the electrical signal from the cell body to other neurons. So synapses, the point contact between the axon of one cell and the dendrites of another regulating chemical connecting whose strength is. Did you understand these things, right? No, right? I also didn't understand those things. So why I'm explaining this, that is the our body, our brain. These are the nerves in our brain, and these are like if cutting our finger, so is cutting blood bleeding and those things is doesn't do this finger is a decided like our brain has to tell to us that your finger has cut and this place has a bleeding and this is the paining in this location. We are just pressing this location and we say that oh pain in here is not pain by this finger, is telling to our brain, is telling to us. So this all thing is connected with our brain to is coming with the axon, and axon is going on this place, and there is a cell body that is in the brain. As where is this connection is in our brain, and there is a cell body, and that cell body has this nucleus is the providing to decision that okay you have a something unusual is happening in your body things, and these are the giving to other informations to other places things, other brains, other informations things. So these are the dendrites, that's called the connectivity between these cells to making those other part of connections, that is dendrites things. So based on this concept we have to define our whole neural network applications. Neural network has designed based on this concept completely. So they are using artificial intelligence, that is called the ANNs, artificial neural networks. That artificial neural networks as a learning from the examples, labeled, unlabeled, adaptivity, changing the connection of strength to the learn, non-linearity, the non-linear activation functions are essential, fault tolerance, if one of the neurons or connections is the damage, the whole network will works quite well. So thus they might better alternative than classical solutions for problems characterized by the high dimensionality, noise, imprecise or imperfect data, a lack of clearly stated mathematical solutions of the problems of the algorithm. So neural network, they are giving to models of brain and nervous system, highly parallel, process information much more like the brain than serial computer, and is learning process that is a very simple principle and but very complex behavior. So the application is powerful problem solver and biological model itself. So how this node is structured in the neural network? In the, as you know that network is there, that is the definitely some node, right? They are connecting, providing the networking between the nodes, those things. So how do we structure a node? Node has a squares, and they have some input and this is the 4.7 is the value of weight, value is random values they can use, and then it gives you the output, these things. How this is gonna be work, like squashing functions limit node output, they use the activation functions. These are the activation functions. How? Let's see. To first I just explain. This is the neuron model. This is the oculus nucleus, and you provide the axon, synapses, and dendrites. They make it these answers, these things. So see, and they using to feed forward networks. Feed forward networks means information flow is unidirectional way. So the data presented in the input layer passed on the hidden layer and passed on to output layers. So information is distributed and information processing is parallel. So for example, like this, we have this input. Given the input, they have feature extracting and matching those feature with the other input, one to other inputs, and make that hidden layer, make the connection between those hidden layer. We providing to these are the weights. Weight is the some random values. We can assume that this value were gonna be used to connecting those things, and after the weight, we have calculating the data and give us to represent output. So that is the information, and these are the internal representation of interpretation of data. So like feeding data through network, it is the input, we have this weight calculations, and then we have this output one. So how to calculate this value? I'm talking about this value with this. So that here we have this value 1. These are the input values. We giving the 0.25, 1 minus 0.5, 1.5. The answers, the what is the hidden value is comes like this way. 1 multiply with this plus 0.5 multiply this, and then it will be make this hidden layer values, and then again in the hidden layer is doing this process again, and then give that our output, final output of this. And for the squashing, they are using 1 divided by 1 plus e to the power 0.5 exponential and calculating by 0.3, these things. So weight is has some advantage and disadvantages. Advantage is it works relatively fast. Downside, requires a training set, can be slow, it's probably not biological realistic. Alternative to the back propagation, where is a hidden layer, that is not Hebbian layer, that is a hidden layer. Not successful in feed forward networks, reinforcement learning only limited success, and artificial evaluation, that is the more general but can be even more slower than back propagation things. So these are the using to biases. For the example, these are the input x0 to xm. We have this weight value, weight I for the input x, and there is a bi, that is a biases. So we can collect those all synaptic weight, that is blue one is called the synaptic weights. We have to this neuron, they are summation of this whole values, all connected value, then we use to activation function and then give the output. So what is the biases is using to the biases represent the a, that function of n to the power I, the I of nth value of I. So that is the summation of weight, ith weight to v j multiply with the input x j plus bi, and that is the calculated by the biases. So the artificial neurons compute weighted sum of its input called the network input, added its biases and passes this value through the activation function, and we say that the neuron fires and become the active if its output is above the 0. So biases can be incorporated as the another weighted clamped to fixed input of the +1 and the extra free variable biases, that is called the extra free variables, to making the balance things to make the neuron more powerful. So we have to, other words, we can use this activation function. What is the activation functions is the called squashing function, and as its limit of the amplitude of output of the neurons. This value has the belonging in different we have different activation functions based on our applications. So but mostly we use to sigmoid and the tangent one. So there are many type of activation function are used to, like linear one, a f functions, and their threshold is a belongings to between the 1 and 0, so that is hard limiting. That sigmoid is belonging 1 divided by 1 plus exponential power minus 10, like this way we can see here. These are the hard limit, symmetrical, linear, square, saturating linear, symmetric, saturating linear, log sigmoid, hyperbolic, tangent, positive linear, competitive. So these are the some activation function when we use to this neural network model. We need to use this, is compulsory to use to make the balance, make the execute answers of this. So there is like hard limit belong to between 0 and 1, their limit, and the symmetric hard limit is -1 to +1. That is a linear one is just n, and saturating is the n 0 to 1. Between n is also there belonging to less than greater than n is a greater than 0 and less than 1, and symmetric is others. It's the, so we can see there is the highest one is 1 to -1, +1 to -1. They belong to the whole activation function. So with the help of this sigmoid function, this one functions, we are able to reduce the loss during the time of training, because it eliminates the gradient problem in the machine's learning model while training, like NumPy and this training system. So they have some like gradient and those fail. Why we are using this activation function? So example, if we are at a, someone is going to the some hill, and there is a coming to fog or cloud, and we cannot, our visibility is very low front of this. So what we assume, based on our assumption, we are moving, we are following the path, right? So that assumptions value, the here is that this sigma, this activation function and this gradient, they are providing that assumption value. You can use those assumption value with your data, with your neural network program, so get it the exact output. So we are giving the input, but we don't know the answers. So we are assuming that we give them something. Okay, this is approximately this much and this much. So we give them that value, and based on those values, our evaluation and calculations, the system will provide the exact output. So that's why we are using this activation functions and biases, and like that is weight for this thing. So they have calculating the our gradient database, gradient descent to our system, our input things. So next we go talk to about neural network. So neural network is a massively parallel distributed processor made up of simple processing unit, that artificial neurons. It resembles the brain in its two respects. Knowledge is acquired by the network from its environment through a learning process. Synaptic connections they are providing to strength among the neurons are used to the store acquired knowledge things. So we have multiple different topologies, neural network topologies, like single layer feed forward, input layer projecting into output layer. For example, like this is the simple single layer feed forward network. Second, we have to multi-layer feed forward network. There is one or more hidden layers. Input projects are only from the previous layer onto layer, and typically only from the one layer to next layer. In here we can see that these are our output is here. This is the one hidden layer, that is single layer, single feed forward one, and here there is the multiple hidden layers. This is, so that is called the output. That is the multi-layer hidden multi-layer feed forward networks. So it has a two layer or one hidden layer fully connected network things. And third, we have to recurrent network. So recurrent network is a network with the feedback where some of its input are connected to the sum of its output itself. That is called the discrete methods, discrete time, that is discrete time. So we have applications of ANN like pattern recognition, function approximation, associative memory. Early ANN model has a perceptron, Adaline. So these are some examples or to where we can use this ANN model. So next we will talk about this, how to decide on network topology is input node, number of features, output nodes suitable to encode and output presentation, transfer function suitable to the problem, hidden nodes not exactly known, we don't know what the hidden node is doing, how to perform, how to process the hidden layer itself. So for example, let's see, this is the, I give that input, it input, they extracting the feature in there, then again doing the max pooling in here, again after the max pooling they again do the dividing the features, and again max pooling and again features, and then again this max pooling and again features, and after that it will make this connectivity and find that what is the mention in this image, how what are the information in this image. So they mention that there is a department name, there is a title, there is a persons, there are logo, and there are seminar things. Based on those, based on this process and this feature extraction, the system will be tell to us this what is in this particular image we have. So these are the called the fully connected layers, and they're using the max pooling layer. Max pooling means what the like 64 they're dividing into those small things, and they collecting the highest value from there and doing, for example, this one. 4, 5, 6, 7 they have, and it has like 3, 2, 1, 4. So they are doing the max pooling, is called that they are taking the only value from the 7 is highest here, then 4 is highest here, they are taking only highest value, and then again they are combining these two values and making another sections, another max do the another sections and do the again max pooling and again max pooling. So like this max pooling, then again divided in this form, and then again do the max pooling for this process, and then again do this functions divided in the characteristics feature extraction, and then giving the again max pooling and do the again feature extraction and giving the two again max pooling with the features, and finally they will give the very small amount of the data, this information is happening, and they making the connectivity of the inputs of these things and find that okay, these are this, and give the output result of things like this way. Next we have to the linear model. Linear model is we used to before the weighted combination of the feature values. So we use the Hj and IH sigma lambda j for the, so such type of network is connected like this way. So there is a linear way, only these are the input and they are just directly connected with the output, find the answers. So limit of linearity is we can give feature of weight but not more complex value responsible. For example, any value in the range 0 to 5 is equally good, and values over the 8 are bad, higher than 10 is the not worse. So that type of some problem with this linear model. So that's we introduce the multiple linear model, multiple layer. So multiple layer added the intermediate hidden layer of processing. Each arrow is the weight, each single arrow is the weight, and they have using those weight with the multiply with the input, and they give that answers, that hidden layer process, and this is the output. So instead of computing the linear combination, we have to another non-linearity. Instead of computing the linear combination, we can we have this nonlinearity. So we added the nonlinear functions to our input. That nonlinear function is called like that activation functions. So 10hx sigmoid one on relieve active one activation function. So rectify linear unit, that is relieve activation function they using. These three are the most most activation function we use in our linear models, our neural networks. So that is all about to the neural networks. Now we're going to talk about to deep learning. Why I'm talking about making the separate this neural network deep learning. Now deep learning is going to use these all features, this activation function biases and those input and hidden layers, and they give us to calculating the extracting the features. So what is the main work of deep learning is this: extracting the feature, making the layers, how much layer we are divided our input, and we can get our more exact output. So that is the main function of the deep learning one. And those functions, those actions is using with the help of this all activation function biases and those things. So more layer is deep learning. So that is the as much as layer here. Layer means as much as feature we are extracting. Means as much as we divided our input as much as small parts, and then we are adding those things. So deep learning means what the depth we hold. Each layer is a processing step. Metaphor is neural network and computing circuit. Computer sequence of Boolean gates, neural computer has sequence of layers. So having multiple processing steps allow complex functions. Deep neural network can be implement complex function using, for example, sorting on input values. So let's see example of simple neural network. We have, this is simplest one. This we have input 1 2 3. We are just giving the weights, and that weights is calculating and give that our output. So now one innovation, biases units are no input, always value 1. If we have no input, like this one has no input, so the value is always comes to 1, like this. So next we have to the sample input. We have this inputs are calculating, try two inputs values, hidden unit computation power. We using a sigmoid 1.0 multiply with 3.7 weight, multiply 0.0 to 3.7 weight, and this function. So this way we are calculating one by one to each values of the each functions things. So it comes like computed hidden layer. When we computed this hidden layer, it is hidden layer is giving the 0.9, 0.17, 0 and 1. That is automatically we are giving these values, and compute the output these values. To sigmoid 0.9 plus 4.0 multiply with 4.0, and these equations when we inputted those things, and when we implement our sigmoid activation functions with this, and after computed analysis computed value, we get it the 0.76, that's things, and then we use to binary one. Binary output is output of all binary inputs is 0 0 0 1. We know to these values, right? So everyone know about, I believe that everyone know about the logic gates. So we have this input, and this input when calculated those things, the hidden values are giving these answers. And finally network implement the XOR. Hidden node is H0 is OR, and node H1 is the AND. So final layer operation is H0 minus H1. So power of deep neural network is chaining the processing step, and just more Boolean circuit is more complex computation possible. So now we're going to talk about to the model, that deep neural network models what we have. So first, that is like called the convolutional neural network, CNN. So CNN, you can see this is the one handwritten A to this is the input is 32 cross 32. We have this convolutional neural network. We divided in that part to more 28 to 6 multiply with the 28 cross 28, and then we are taking this subsample. These are the this particular of this image, that pixels, this pixels one. So this much we are subsampling, do the subsampling again divided in the 14 cross 14, and then do the again subsampling, making the full connections, and finding that this full connection will be making the Gaussian connections, Gaussian connections. So they will use to these functions and give that output is handwritten is value is A. So that is the structure of the CNN. How do we calculate, how do we use this convolutional neural network to be divided, how much, that is the defining the feature extraction, how much feature, how much deep we go to some particular image or particular input of these things. So that is the example of this. We have talking about this max pooling and this convolutional layer. Convolutional layer, they are divided into three things: 512 and this 256 and then 128, then 64 and these things. So next, like CNN is standard neural network are directed acyclic graph. That means they have topologically ordering. The topological ordering is used for the activation propagation and for gradient back propagation things. So they process one unit instance of at a time. One by one they are going to follow the actions in the thing. So in here that we have just first follow this value, then again follow this value, this value, this value, then they're going to take too much time to be calculating. So that's why for the deep learning and we require to high processing system calculation, high processing systems things. So next we have to the LeNet. So LeNet is the input is a handwritten digit and output is the probability over the 10 possible outcomes. So the basic of this LeNet is CNN is a network that employs convolutional layers. In a CNN, we interleave convolutional non-linearities and often pooling operations. The CNN convolutional layer is typically arranged that gradually decrease the spatial resolution, and representation is increasing the number of channel. So the traditional CNN is representation encoded by the convolutional blocks are processed and by one or more fully connected network. So LeNet was arguably the first successful deployment of the such network things. So it will using 5x5 matrix, 5x5 layers. They are dividing those things. So this one is example. Let's see that one example of this. So in example you can see this is a LeNet 1989. Recognize the zip code. Jan LeCun, he is the first one who is defining this. So based on his name, this network is LeNet. So Bernard and Bowser and other run live in the US portal services. So they give this input and they divide thus 10 input units, and layer is defined. The hidden layers, the 3 hidden layers they're using. For a third one, they're using the 30 hidden units, and the layer H2 hidden layer 2 they're using 12 class 16 192 hidden units, and H1 they are 12 class 64 768 hidden units they are using. So 256 inputs unit they are providing, and they're giving the fully connected with the 300 link, and 6 are fully connected with this hidden layer is a 6000 and 40,000 in the second hidden layer, and that is called the 5x5 multiplied by 8. They're using to 20,000 links for the first hidden layer things. So they are characterizing, they are defining those things in the small characteristics, feature extracting, and they are connecting those things. In the final, they are providing the fully connected values, and they are recognize that what the input is there. So second, we have deep neural network, that is AlexNet. AlexNet has similar structure of the LeNet, but uses the convolutional layer and larger parameter space to fit the large scale ImageNet data set. So today AlexNet has been suppressed by the much more effective architecture, but it is the key step from the shallow of the deep network that are used nowadays, and key step in achieving excellent performance in the computer vision task. So AlexNet is giving the more accurate answer in the computer vision applications field. So let's see, compare with the both LeNet and this one. So LeNet has the 16 cross 16 and it has the 5 cross 5 data. LeNet has a 5 cross 5 feature extraction, and this one AlexNet has the 11 cross 11 one convolutional feature extraction things. So let's see example. This is the LeNet and this is, so for example this They are using convolutional neural network 2012 train the 200 GB of ImageNet data. They're using to providing the feature of each small feature, extracting those things. So ImageNet object classification perform over the time, like this much time. It will take that much time. Human performance is this, and LXNet performance is that one. So it will be take till 2030 things. Next we have to network using the block VGG. There is a basic VGG 11 structure is network using the reusable convolutional blocks, where VGG network models can be defined in the differences in the number of convolutional layer and output channels in each block. The use of the blocks leads to the very compact representation of the network definition. It allows an efficient design of complex network. In their VGG paper, the synonymous and Jesserman experiment with various architecture. In the particular, they found that several layers of deep and narrow convolutional, they have 3x3, were more effective than fewer layer of the wider convolution. So they are represented like this way, LXNet and this. So what they are doing in LXNet, they're going by the step by step, but VGGNet, they're creating the blocks based on the similar features. They're creating the blocks, and they again that based on those block feature extraction too, they're making the decision on the block by block, they're extracting, and then they are finding the final decisions. Next we have to network in the network, NIN. So network in the network, you also uses the block consisting the convolutional layer and multiple 1x1 convolutional layer. So this can be used within the convolutional stack to allow for the more per pixel nonlinearity. So NIN removes the fully connected layers and replaces them to global average pooling for the summing overall the location, and after reducing the number of channel and desired number of outputs. They using to the 10 of the fashion MNIST data set. So removing the fully connected layer reduces the overfitting NIN, has dramatically fewer parameters, and NIN is designed influence many subsequent CNN design things. So this is the looks like this way. So they have VGG blocks, and these are the NIN blocks. They have divided in the VGG, they using the 3x3 max pooling. In the this one, they dividing the 111, and then again they find the getting the average value of that max pooling one, average value of those all blocks, and then it make the connectivity with this. So they are comparing the comparison. Next we have the Google Net, that Google LANet. They're using those things to implement LANet network. They are improving again with the based on these features. They're making the some inception inside of the block. They are creating the blocks, and they dividing those inception based. They're making the final decision. Not they are showing whole data one by one. They are doing the hidden layer, making the inception of the hidden layers. Again hidden layers thing. So inception block is equivalent to sub network with the 4 path. It extracts the information in parallel through the convolutional layers and different window shape. So the maximum pooling layers, there is 1x1 convolutional reduce the channel dimensionality on per pixel layer, and maximum pooling reduce the resolutions. So GoogleNet connect the multiple well designed inception blocks with other layers in the series. The ratio of the number of the channel assigned in the inception block is obtained through a large number of experiment on the ImageNet dataset. So GoogleNet is, as well as the succeeding version was not one of the most efficient model of ImageNet, providing the similar test of accuracy with lower computational complexity things. So next we have this GoogleNet. These are the structure. The first structure, this is the simple one. We have concatenate 1x1. We do this max pooling. We give them input. The dividing those things, put this structure of inception structure, and then all concatenate with those things. So that is the other same examples. Convolutional 7x7. They divide in the 3x3 and then make the convolutional, and then again here they make the inception of the, and then find out the global average of this whole value and average pooling. They do find the decision, make the connectivity. Then we have to next DenseNet. network, that's densely connected network, that in terms of the cross connection, unlike ResNet, the where inputs and outputs are added together, DenseNet concatenate input and output on the channel dimensions. So the main component of that composed DenseNet are dense block and transition layer. So we need to keep the dimension. Yes, ma'am.
I sorry, I am interrupting you.
Yep.
But it is already more than 1.5 hours, and students, I think, they want break. Or we can do like this. This is very interesting to listen this deep learning. So it would be better if we have next sessions on some day, on especially on deep neural network.
Yeah, I think that is good, because today
Yes, and we want to hear in detail each and every deep neural.
Yes, ma'am. Yeah,
Okay.
sure, ma'am. You can do that. Actually, just for now, only 4 slides is remaining thing. So
Okay,
that's
okay. So you can no problem.
So that is just like, yeah. So yeah, these are the dense network. Then we have to recurrent network, that are using the large scale time. Large short time model. That is the using this. Ma'am, we can start the next time. I think we go for the next. That is good.
Okay, yeah, it would be better if we go in detail in each and every these deep neural network.
Yeah, that's I'll go with the next.
So I am again so that everyone can unmute. So if you are having any question, please ask. Maybe some questions we are having in chat also. In chat box.
No questions till now.
Any participant, if you are having any question, please ask.
If not, then we'll keep it the question for the next session when we go for the next session, deep learning. Yes. So that is good. Actually, I believe that there is also not too much deep, so there are some issues. So I'll take the next.
Thank you so much, Dr. Madhusudan.
Thank you.
So now for the remaining participants, I am very happy to say that Dr. Madhusudan, as earlier one of my favorite students in IIIT Allahabad, and now he is working, he is doing very good, and that's why I invited him. And in future also, I invite you for this deep neural network. Okay,
sure, ma'am. Sure. Yeah.
Thank you so much.
Okay. Thank you, ma'am. Thank you.
Okay, bye. We'll meet again soon.
Yeah, sure.
Bye.
Thank you. Bye. Good day.
Thank you, ma'am.
Thank you, ma'am.
Welcome.
Thank you, ma'am. Thank you, sir.
Can I leave, ma'am? Now?
Thank you, ma'am. Thank you, sir.
Thank you.
Thank you, ma'am. Thank you, sir.
Thank you.
Thank you, sir.